right, so we're going to continue digging into polynomials, and we're going to start looking at how they behave. There's a lot to get into as far as how polynomials behave, how you can kind of detect what's going on. But the first thing we're going to look at is end behavior. The reason we're going to look at end behavior first is, first of all, it's a big deal, and second of all, it's really easy to figure out. So earlier we looked at this first term, and we found the leading coefficient, and we found the degree. Well, just based on the leading coefficient and degree, we can tell what's going to happen at the ends, okay, at the far right end and the far left end of these polynomials. Now, the reason it works like this is, so out of these three terms, this is the big dude. He's in charge, okay? As x gets big, this guy is going to take over on the far right end and the far left end. So this guy is going to determine your end behavior. So it's going to all come down to this leading coefficient and this degree. So I want you to think about it. We've learned how even and odd functions look. So we know that parabolas and fourth power and sixth power all kind of make this parabola shape, okay, ish, okay? Only the second power is technically a parabola, but if we took those and we made them negative, all of a sudden they look like this, okay? So negative second power, negative fourth power, negative sixth power, negative eighth power, they're all gonna be like this. Positive even power is gonna look like this. Positive even degree, I should say. What if it's odd? Okay, well, we kind of know what these cubic functions look like. Okay, they're kind of this action right here. But same thing with fifth, seventh, whatever. If you make them negative, they go the other way. So the thing is, though, we don't know what's going to happen in the middle of the graph, but we do know what's going to happen in the ends. So if the degree is even and A is positive, then the end behavior is going to look like this. Now, the way that it's going to ask this on your assignment is it's going to say, what happens as x goes to infinity? As x gets really, really big, what happens to y? Well, you can see that y goes to infinity. So as x goes to infinity, or f of x goes to infinity. As we go to the left, okay, what happens as we go to the left? As x goes to negative infinity, as x gets really, really small, same thing happens. We explode out. We get this f of x goes to infinity. So these are a fancy way of saying that it goes like this on the ends. Okay? What if the degree is odd and a is greater than 0? Okay? Well, it's going to do this action. Again, we don't know what it's going to happen in the middle. It could like dip and do some stuff in the middle, but the end behavior is going to look like this. So as x goes to infinity, f of x also goes to infinity. As x gets really, really big, y gets really, really big. But here, as x goes to negative infinity, y goes to negative infinity. Okay? So this is if the degree is even, this is if the degree is odd, but what about, and if the leading coefficient is positive, but what if it's negative? Well, we know what's going to happen. So if it was this guy, now it's going to do this. So if A is less than 0, we're going to have this guy right here As x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y goes to negative infinity. Well, what if it's odd and we have this negative leading coefficient? Well, instead of doing this, it's going to do this. So as x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y goes to positive infinity. Okay? So that's what the end behavior is doing. So let's look at these and let's see if we can just sketch what's going on based on these rules that we've learned. So this guy, our leading coefficient is positive, our degree is odd. So it's odd and it's going the way that we expect. So this one should look like this. So as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. This guy, this has 1, 2, 3, 4 roots. It's degree 4. So if I multiplied all this out, I'd have x to the 4th. And then my leading coefficient is negative 2. So since it's a 1, 2, 3, 4 even degree, it's going to look like this. Since it's negative leading coefficient, it's going to look like this. So we're going down like this. So as x gets bigger, we go to negative infinity. As x goes to infinity, we go to negative infinity. As x goes to negative infinity, y goes to negative infinity. So it's like this. What about this guy? This guy is deceitful. You may think, oh, we have 1, 2 roots. No. Look at these powers. If I wrote this the long way, you'd see, oh, this guy shows up 3 times. This guy shows up 2 times. So we have a leading coefficient of negative 7. We have a negative leading coefficient. Our degree is 1, 2, 3, 4, 5. So it's an odd degree, and it's negative. So we're going to look something like this. As x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y goes to positive infinity. So we already have this gut feel for how our polynomials are going to look just at a quick glance. Okay, you should be able to almost sketch them. And what we're going to do in a minute is we're going to use these to find our x-intercepts. This is a little trickier to find our x-intercepts. But we can find our x-intercepts and our y-intercepts really easily in this form.